Oh, morning, ladies and gentlemen. So we're starting a new unit. This is going to be on Pythagorean theorem. To do that, though, we have to do a little bit of a review on squares and square roots. So we've been chatting about this since the beginning of the year. I'm sure none of what I'm about to show you is new, but again, the refresher's good. So when we see 2 to the exponent 2, we could say that's 2 squared. And we know that that means 2 times 2, which is 4. Then if we're just going through some of the other common square roots, or squares, sorry, 3 squared means 3 times 3, which is 9. 4 times 4 is 16. 5 times 5 is 25. Okay? So what that means, if you see square root 4, so that this square root, this is the opposite operation of squaring something. So squaring, square root, kind of like multiplying, kind of like dividing. So this is saying what number multiplied by itself twice gives you 4, so it's going backwards. And of course, it would be 2. What number multiplied by itself twice gives you 9? Well, we see over here, 3 times 3 is 9, so square root 9 is 3. So you can see square root is taking from the perfect square and going backwards to its root, or the number that it started from. Okay, that's why it's called square root. So 4 times 4 is 16, and 5 times 5 is 25. Okay, with that idea? So what they're going to do here, so here you can see the beginning of the lesson. So it's starting on page 329, and it's called Estimating Square Roots. So the idea here, figuring out what the answer to the square root is without using a calculator. And you're going to do it just by knowing the answers to your perfect squares. Okay, so we get a bunch of square roots that they want us to find. I'm just going to move it there so we get out of the way of that stupid watermark at the bottom. Okay, so square root 2, square root 5, square root 9, 18, and 24. And we see a number line, 1 to 5. So this is just the normal numbers, 1 to 5. So what I'm going to do is put up what these would be if they were squared. So 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. Okay, so let's start with the first one, square root 2. Well, we know square root 2 is larger than 1 because 1 times 1 is 1. It's smaller than 2 because 2 times 2 is 4. So root 2 is somewhere between 1 and 4. What's it closer to? Is it closer to 1 or closer to 4? Well, it's closer to 1. So let's put square root 2 right there, okay? Because it's closer to 1 than it is to 4. Root 5, or square root 5. Well, we know that 2 times 2 is 4. 3 times 3 is 9. So we know it's between 2 and 3 because it's bigger than 4, less than 9. What's it closer to? Well, it's closer to 4. So we'll go and we'll put square root 5 right there. And then square root 9. Well, I know that 3 times 3 is 9, so square root 9 is going to be right there. You know, that is 3. And then 18, well, 18 is larger than 4 times 4 is 16, less than 5 times 5 is 25. So it's not a lot bigger, so maybe it'll be there. And then root 24, well, it's just less than 5 times 5. So we'll put it right there, square root 24. Okay, so hopefully you get the idea. Then down at the bottom, you can see that they're asking us to figure out square root 20. So using the same kind of thing, okay? So I'll use a number line. And we're just going to start with some common squares. So we know that square root 20, it's going to be bigger than 4 on a number line because 4 times 4 is 16. So we're close. Now we go up to the next biggest. 5 times 5 is 25. it's too large. So we know it's between 4 and 5. I can get rid of this now, and then I'll scroll up. So we know that it's between 4 and 5, but where does it go? Well, square root 20 is 4 away from 16 to 20, 5 away from 25. So it's about halfway between square root 16 and square root 25, but just slightly closer to 4, right? Because it was only 4 away from root 20, 5 away from root 25. So we're going to say it's about 4.4. So on a number line, if there's 4, there's 5, that would be 4.5. Square root 20 would be about here, estimating that it's about 4.4. Okay, so that's the idea. Think of, on a number line, what the square of each number would be, and then when they're asking you to find the square root, you just put it between those perfect squares that you do know. And that's why in the classroom I had all those perfect squares put up over the number line, right over the chalkboard and the smartboard, so that you just kind of got used to seeing them. Hopefully a lot of them are committed to memory, or you just, because you know your multiplication facts, you know what they are. Alrighty, so that's about it. Yep, I can't think of anything else. Okay, bye for now.